Hello, this is Chuki Chen, and welcome to the Choosing the Right Layout module. In this module, I'm going to go over how to decide which Android layout to use, a very useful tool called Hierarchy Viewer which lets you debug and examine your layouts, several techniques such as merge, include, and view stub to optimize your layout, and finally, a few case studies to exercise your brain and see how you can implement layouts in different ways. Which layout to use? The first rule of thumb is pick the simplest one that can do the job. Don't over-optimize. First, figure out how you can put the views on screen the way you want it. And then, once you do that, you can go ahead and analyze its performance and see if there are places that you want to improve. So, which layout can do what? The four layouts we covered in this course, linear layout, relative layout, frame layout, and table layout, can be divided into two groups. The first group deals with one dimension only. Linear layout deals with the x-axis or y-axis, so you can put some views horizontally or vertically in a row. Frame layout deals with the z-axis. You can put views on top of each other. The second group deals with two dimensions. Relative layout allows you to put views relative to each other. Table layout is good for aligning columns. It allows you to take data that have variable width and put them together into columns that line up. In terms of performance, it is important when you are using a layout repeatedly. For example, if you have a list view and each list item consists of many nested items, that may drag down your performance. In general, when you have fewer views, your performance is better. This is because Android have fewer things to keep track of in terms of where they are and what people click and touch. Another thing to pay attention to is measure passes. The fewer measure passes, the better. What do I mean by measure passes? When you give Android a layout, it needs to figure out how to put it on screen. Android goes through three phases: measure, layout, and draw. Let's step through a concrete example to understand what I mean. This is a linear layout with two children in it. Both are text views, one containing the string hello, the other one containing the string world. Let's pretend that we are the Android system. How do we decide where to put these views on screen? The first thing we'll do is measure. We will go through the linear layout one child at a time. We look at the first text view and see that it contains the word hello. We figure out which font we are using, how big the size of that font is, and then figure out that we will need a box measuring width 65 and height 38 to contain the word hello. We can do the same with the second text view for the word world. This time the width needs to be 74. After we have done the measure phase, we can go on to layout. When you're laying out, that means you're determining the position for the top left corner and the bottom right corner of this view. For a linear layout, we start at the top left, so we assign the top left to 0, 0. And the bottom right corner depends on how large this view is. This is why we need to do measure before we lay out. In our case, we will put the view at 65, 38 because that's how big the word hello needs. Next, we will move on to world. When we do the top left corner, since this is a horizontal layout, we will put this view at top at 0, but left at 65 right after the word hello. For the bottom right corner, it is simply a matter of adding the width to the left, so 65 plus 74 is 139. And the bottom is adding the height to top. So 0 plus 38 is 38. Now that we have determined the position of both views, Android can go ahead and draw them on screen. Let's look at another example where we're using layout weight. This time, the measurements part is a little bit more complicated. Again, we walk through the views one by one. The first one, the text view with the word hello, says that it has 0 width and weight 1. This means that we will need to figure out how much remaining space this linear layout have and divide it and give this view weight 1. But we can go ahead and determine the height. So we'll write down height is 38. The next view is still wrap content, just like the last example. So we can go ahead and measure it to be width 74 and height 38. Now that we have measured all the remaining views of this linear layout, we can go ahead and measure the first view again. We will take the width of the whole linear layout and subtract 74 from it to determine the width for the first view with the string hello. The width of the whole linear layout happens to be 720. So 720 minus 74 gives us 646 for the text view hello. Now that we have obtained the measurement, we can do the layout just like the last example, putting the first text view at 0, 0. This time, the bottom right coordinate is at 646 and 38. This is because the word hello takes up a lot more space than last time. For the text view with world, it is similarly placed. Since this is a horizontal linear layout, the left position of the second view is the same as the right position of the first view, meaning is 646. The right position of the word world is again the left plus width, so it becomes 720. The bottom is top plus height. We have seen that in linear layout, if you are not using weight, you just need to have a single measure pass. But if you are using weight, you will need 2 passes. How about the other views? How many measure passes do we need? Relative layout always need 2 measure passes. This is because the constraints are specified relative to each other. Frame layout is very simple and it always takes a single measure pass. For a table layout, it at least needs 2 measure passes. The first pass computing how much space each view takes, and the second pass will go over each column and expand the views to be the same size as the column with the widest width. If you're using stringing or stretching, then it will take an extra pass to distribute or trim the extra space. To reiterate, you need to pay attention to performance, especially when you are using a layout repeatedly, for example, in a list view. In general, the fewer views, the better the performance, and also the fewer measure passes, the better the performance. Besides using these rules of thumb, Android provides a very useful tool called Hierarchy Viewer, which allows you to examine your layout and figure out how many views there are and how long it took to measure, lay out, and draw them.